to think of. What do you know about magnetic levitation trains? They don't touch the track. Very nice. Okay, how about we go over here to the right? What did you guys come up with? Where it's made, good. Do you know where it's made? Do you know where they were first started? Excellent, Germany, yeah. It's amazing how a lot of technologically advanced technologies come out of Germany. We'll look at that more later too. Anything else? Okay, I should indicate it's founded. Okay. So based on this, what else can we say? Based on this founded in Germany, what do we notice about magnetic levitation trains? Where do they mainly exist? Japan, yeah, Japan is a very nice one. Okay. And Europe in general, very nice. So what do we see? We see the trains, these high-speed rails, mostly exist in Japan and Europe. And we know that these magnetic levitation trains are indications of high developmental countries, okay? So that kind of brings you to wonder, why don't Canada and US or Australia, why don't any of these countries have magnetic levitation trains? It provides a more efficient travel route. Both Canada, United States, and Australia are very large countries, okay? So why don't they have it? So that's what we're going to look at right now, okay? So does everyone have this concept map written down? Okay, okay, I'm going to erase it now. Okay, so now I'm going to show you a brief, I'm going to give you a brief idea about how magnetic levitation trains work and how they can achieve such high speeds. Okay, we're going to go more in depth into this subject tomorrow, but for now, hopefully this simplified explanation will satisfy you. Okay. Imagine these two rectangles are the tracks of the train, okay, of a magnetic levitation train, okay? And what we're gonna have is, okay, I'm gonna let the train be represented as a single magnet, all right? Generally speaking, a train will have multiple magnets all down its axis, okay? But for simplification purposes, we're gonna show it as one magnet. This magnet is going to have a north and south pole, as do all magnets, okay? And on the track, I'm going to put more magnets, okay? So notice up here on this track and down here on this track, I have put magnets, the south pole of a magnet, okay? And a little bit in front of that, I'm going to insert the north pole of another magnet. And then after that, I'm going to have the south pole. Now, what we learned in grade 11 is that, well, just like with particles, like charges repel and opposite charges attract. The same as with magnets, okay? Opposite polarities attract. So north and south are attracted to one another, and north gets repelled by another north altered magnet, okay? So let's say the train is going this way. Notice what happens. The north end of the magnet is in front, and it gets attracted to these south polarity. I just invented a new word. The north end of the magnet gets attracted to the south poles of these magnets, so it gets pushed forward. As soon as this magnet goes through this gap right here, these two magnets, which are slightly in front of the south pole magnets, switch to south, okay? So they are now south polarity, and these ones become in north polarity. So as this magnet travels through, the south will get repelled, it will get pushed forward, and it will get attracted to the next set of magnets. So basically what happens is the magnets that are aligned along the rails keep switching polarity, so it pulls the train forward. It gets attracted, then repelled, attracted, then repelled, and it basically pushes itself forward. And again, this is an example of an amazing train that actually propels itself without using contact. So it's pretty amazing. Now, if my amazing artistic skills weren't enough to convince you or help you understand how these trains work, I've actually gotten together an animation for you guys. So I'm going to have you watch that. Hopefully that'll help deepen your understanding or better your understanding of how these trains work. Okay? So let's watch that.
Here in Germany, engineers are testing an experimental train that all but eliminates track friction. Because the train doesn't ride on tracks. This train literally floats on a magnetic field. It's called maglev, for magnetic levitation.
Maglev technology is doing what a typical train does, except using electromagnets. Instead of having wheels and rails, we have magnets to lift and guide the vehicle, and then a non-contact propulsion system to propel the vehicle down the track.
Okay, so that was basically a video about how the magnetic levitation trains work. Okay, are there any questions about what you just saw? Nothing? Okay, well, if you think of any questions along the way or after class, feel free to approach me. Okay? So now we've looked at the physics of a magnetic levitation train and good uses for it. So now we're actually going to look at something else. We're going to look at the impacts of such trains, of such a technology, on the environment. Sorry, not just the environment, society, environment, and individuals. Okay? These are actually three very proponents you need to consider before installing or initiating any new large thing, okay? Now I know that sounded really vague, but basically what I mean is before you can actually implement something new, you have to think about how it's going to impact society. How will the city benefit or not benefit from the implementation of such an object or device, okay? How will individuals respond to it? Will it benefit them or will it not benefit them? And finally, you have to look at the environment. Okay, is it going to increase global warming, for instance? Okay, is it going to increase the amount of emissions? Things like that. So let's actually look at that. Let's form a table and see what you guys come up with, okay? So that table is going to look like the following. So copy this down in your notebooks. So this is basically a table that just looks at society, individuals, and the environment. Now I want you guys all to take about 2-3 minutes. Okay, let's say 5 minutes. Think, pair, share. and try to come up with impacts on each of these three factors, okay? And then we'll take it up. We'll see what you guys came up with. Okay, everyone, let's bring it back. Let's see what you guys came up with, okay? So who would like to give me the points they came up with for the impacts on society? Yes. Good.